Hello everyone, my name's Dr. Vile. Welcome to my A-Level Chemistry YouTube channel, where the aim of this YouTube channel is to prepare you for your A-Level Chemistry exams. And this particular video is carrying on the series looking at organic mechanisms, and we're going to focus on the elimination of a halogenoalkane to produce an alkene, and we're going to see the reagents and the conditions that are required for it, and we'll look at the mechanism as well. Want you to think about is if you take a halogenoalkane, let's just say 1-bromopropane. Let's draw it out, 1-bromopropane. And if you treat that with sodium hydroxide, so you've got NaOH and you reflux it, the conditions matter hugely. So if you use aqueous sodium hydroxide, then what happens is the OH minus swaps for the bromine and you end up with an alcohol. And in this case, you'd end up with propan 1-ol. And the reaction that's taken place there is the nucleophilic substitution mechanism. And if you want to find out more details about that, please see the video on nucleophilic substitution. However, what happens if you take your sodium hydroxide and you reflux it, but this time rather than dissolving the sodium hydroxide in water, you dissolve it in ethanol and you reflux it. A completely different reaction happens. You end up with a product that's got 3 carbons in it, but rather than having single bonds, you end up with the double bond. So you end up forming propene as the consequence. So you'd end up with propene, and what's happened is an elimination reaction. And on the next slide, I'm going to talk you through the mechanism for elimination, how it differs. The key point is in the first one, in the nucleophilic substitution, the OH minus acts as a nucleophile and substitutes for the bromine. So if we think back to how that actually happens, I'll just quickly draw the mechanism. The OH minus attacks this carbon here, and you end up kicking out the bromine, so you end up with nucleophilic substitution. However, in the elimination reaction, it is a little bit different. Let me just get rid of the curly arrows, and I'll talk you through how it happens. When you have the elimination reaction, you still have your OH minus. Let's just draw that here. And what happens is the OH minus acts as a base. It removes this hydrogen here to form water. So water is the byproduct. And then this bond here breaks and pushes the electrons in to form a double bond. And then you kick out the bromine here. So the byproducts would be water and sodium bromide. Whereas here in the nucleophilic substitution, the only byproduct is sodium bromide. So that's the difference between the two mechanisms, and this is why this one is called an elimination reaction, and it is a way of forming an alkene. Just to put a bit of clarity here, sometimes what will actually happen is you end up with both processes happening, and you end up with a mixture of the alcohol and the alkene as the product. It's not always as clean cut as this, and it does depend on the choice of halogenoalkane and so on. But for the purposes of A-level, we just need to know the difference between nucleophilic substitution and elimination. And the key difference is, for nucleophilic substitution, we dissolve the sodium hydroxide in water, For elimination, we dissolve the sodium hydroxide in ethanol. Anyway, thank you for taking the time to watch this short video. I hope it was helpful. If you liked it, please share it with your friends. Please like the video, please subscribe, and I will see you on the next video.